In studying the finances for any project, whether it is a PV system or something else, we need to take into account that money in the future is not worth the same as money today. Suppose I am starting a multi-year project. If I have a $500 expense at the beginning of the project, then I need to have the entire $500 today. On the other hand, suppose I have an expense that I don't need to pay until 3 years into the project. How much money do I need today to be able to pay the $500 expense 3 years from now? Well, if I know that I can invest money securely at, let's say, 3%, then I don't need the full $500 today. I only need enough now so that I can invest it at 3% interest and have $500 when I need it. The amount I need now comes out to $457.57. So, at the beginning of the project, I only need to set aside $457.57 in a secure investment, knowing that it will grow to $500 by the time I need it. We say that the present value of the $500 expense in 3 years is only $457.57. Let's take another example. Suppose I know that the project is going to bring in $500 of revenue 3 years from now. How much is that future revenue worth today? Well, it's not worth $500 today because we don't have the money today. But we can take a loan against that future revenue. Suppose we can find a lender who will lend us money today at a 4% interest rate, with a payment of $500 at the end of 3 years. We can't borrow the full $500 because then we won't be able to pay the interest on the loan. But we can borrow $444.50, and then we'll be able to pay back the entire loan, including the 4% interest, with the $500 we'll have. So the present value of our future $500 revenue is $444.50. We evaluate the finances of a project by comparing the sums of the present values of the expenses and the revenue. Often these are distributed over the project, but to be fair, we consider values of all of them at the beginning of the project. The general term that we use for the rate at which future money is less valuable is called the discount rate. In our previous examples, we used R equal to 3% as the interest rate for secure investments where we can save for coming expenses, and we used R equal to 4% as the interest rate on loans against our future revenue. There are also other options for choosing R, and this is a lengthy topic in courses on finance. For us, it is important to remember that R may not be the same for expenses and revenue. It also may change over the course of a project. Sometimes you'll want to use one value of R for the first few years of a project and a different value later on. Lastly, since you may not be certain what an appropriate value of R will be many years in the future, you may want to try your calculation with different values of R to determine how it affects your result. In the previous example, we calculated the present value of a $500 expense 3 years in the future. We assumed R equal to 3% per year, compounded yearly. We can calculate $500 divided by 1 plus the discount rate for each of the 3 years until the expense. We could also use monthly compounding, which may be closer to how interest would actually be calculated for a deposit or loan. In this case, we calculate a present value of $457.02, which is not very different from the value calculated with yearly compounding. Sometimes we have a project in which the same cost occurs on a regular basis. For example, there might be a yearly maintenance expense. Suppose we need to spend $100 at the beginning of a project and then yearly for 5 years. For a given discount rate R, we can calculate the present value of the sum of the expenses using this formula. The term on the right here can be found in tables and some calculators. However, the whole calculation can also be laid out directly on a spreadsheet, as we'll look at next. The net present value is the sum of present values of all of the expected revenue minus the expected expenses of a project. In general, it is considered to be a good investment if the net present value is positive, meaning that the present value of all of the expected revenue is greater than the present value of all of the expected expenses. It is considered to be a bad investment if the net present value is negative, meaning that the present value of all of the revenue is less than the present value of all of the expected expenses. We'll show this by putting the positive net present value in black and the negative net present value in red. However, as we've seen, this only shows how good a project is from an investment perspective, and there are many reasons why an owner may want to do a PV project even if this analysis shows it in the red.